Hello and welcome to this video on analog filters, specifically self-oscillation in analog filters. We're going to look at the transistor ladder filter from Synthesizers.com, and then we're going to look at the Ripples Eurorack filter from Mutable Instruments. But first, say hello to Gizzy. If we're going to play the filter from a keyboard, we're going to have to send the pitch output to the 1 volt per octave input of the filter, and we're going to have to send the gate output to an envelope generator. You could use this one. Then we're going to send the output of the filter to a voltage control amplifier. And we are going to use the envelope generator to open and close the sound every time we press a key. Now the filter goes into oscillation whenever we bring the resonance high enough. At higher frequencies it will oscillate around 6, but at lower frequencies we have to turn it up to all or 10. So in order so that we might hear it, we can open the amplifier by bringing up the gain here, and then we will turn up the resonance until it starts to self-oscillate. And it started to do that around 8. Now we have to tune it with 0 in on the octave. So we have pressed the key, which gives us 0, or if you want to pull out the 1 volt per octave connection so that there is 0 offset, we can tune it to a low frequency with a standard chromatic tuner. Well, you can turn it a little higher and go a little lower. Okay, so that's set to low C there. And now as we play up the keyboard, the filter goes all the way up to 20 kilohertz, which is basically above the range of human hearing for most people. And it's a good sine wave when you view it on the oscilloscope, even in the ultrasonic region. Along with other musical instruments, if we want, you would mainly want to use this filter as another oscillator, perhaps mixed with other audio, maybe several oscillators combined. So you can use your filter as a perfectly tunable sine wave oscillator in your rig if you want to. Now the last observation that we would make before we move on to the Eurorack filter is that the transistor ladder filter, the amplitude of the waveform, it depends to a certain extent on the frequency. In other words, it's not a continuously stable output level across the entire frequency range. We're now on our Eurorack, and we're going to plug our CV from the mutant brain into the voltage per octave input of mutable instruments ripples, and we're going to plug gate output of the mutant brain into the CV input of our VCA, and we're going to plug the low pass output of the mutable instruments ripples into the input of our VCA, and we turn up the level on our VCA, and when we raise the resonance knob sufficiently high, we get oscillation. Just like we did with the other one, and we can tune it with this knob, the frequency knob. Alright, that's pretty much tuned to low C. Now when I play the keyboard, so once more we can play conventional keyboard through the filter, and the filter becomes an oscillator, and as you can hear, it's a pure wave as well. The ripples is going to give you a constant output across its range because of the additional circuit that stabilizes the change in level over frequency. But it's still going to be a sine wave. Any analog filter that oscillates is going to produce a sine wave. Self-oscillation always produces sine wave. Thanks for watching, and see you in the next video.